On certain summer days, the air itself seems to vibrate. A rising wall of sound pours out of the trees, swelling until it fills entire neighborhoods with a steady electric buzz. The source isn't a machine or distant traffic, but thousands of small insects hidden among the leaves. Cicadas are famous for producing one of the loudest natural soundscapes on Earth, yet the way they generate that sound is far stranger than most people imagine. These insects aren't rubbing their wings together like crickets, and they're not simply buzzing the way flies do. So how does such a small insect create a sound loud enough to dominate an entire landscape? Let's explore the science behind their famous summer chorus and answer this question right here on History of Simple Things. The key to a cicada's noise lies in a specialized structure called the timbal. These organs sit on each side of the male cicada's abdomen and act as the insect's main sound-producing mechanism. A timbal is a thin membrane made from the cicada's rigid outer shell, reinforced with rib-like structures that allow it to flex. Strong muscles pull on this membrane, causing it to suddenly buckle inward. When the membrane snaps out of shape, it produces a sharp clicking sound. As the muscle relaxes, the membrane springs back to its original position, creating another click. This cycle repeats rapidly while the cicada is calling. Unlike many insects that produce sound through friction, cicadas generate noise through the rapid deformation of their exoskeleton. The timbal effectively works like a tiny biological drum that produces repeated pulses of sound. A single timbal movement produces only a brief click, but cicadas repeat this action extremely quickly. Their muscles contract and release at remarkable speeds, sometimes hundreds of times per second. Each contraction can cause several ribs on the timbal to buckle in quick succession, producing multiple clicks in a rapid burst. Because these pulses occur so quickly, the human ear cannot distinguish them individually. Instead, the brain blends them into a continuous tone. What we hear as a steady buzzing sound is actually a rapid stream of mechanical pulses created by the insect's body. Different cicada species vary the rhythm and intensity of these pulses, giving each species its own distinctive call. The familiar summer drone is therefore not a single sustained note, but a dense series of clicks occurring faster than our ears can detect. Producing vibrations is only part of the process, because cicadas must also make those vibrations loud enough to travel through the environment. Much of a male cicada's abdomen is hollow and contains air sacs that function as a resonance chamber. When the timbal produces rapid clicks, those vibrations spread through the abdomen and resonate inside this hollow space. The chamber amplifies the sound in a way similar to how a musical instrument strengthens vibrations from its strings or air column. This system allows cicadas to reach impressive volumes, sometimes exceeding 100 decibels in certain species. For an insect only a few centimeters long, that level of sound production is remarkable. The amplified calls can carry through forests, fields, and neighborhoods, allowing cicadas to communicate across long distances. Despite how common the sound seems during cicada season, not every cicada produces it. In most species, only males possess the timbal organs needed to generate loud calls. These sounds play an important role in reproduction. When cicadas reach adulthood, males begin calling from tree branches to attract females. Each species produces its own distinctive sound pattern, allowing females to identify the correct mate among many insects calling nearby. When a female recognizes a suitable call, she may respond with a subtle signal, often by flicking her wings to create a small clicking sound. The male detects this response and moves closer until the pair locates each other. The well-known cicada chorus is therefore not random noise, but a communication system that helps bring males and females together. Although cicadas are known for their loud buzzing, their acoustic behavior includes several types of signals. The most familiar is the calling song used by males to attract females from a distance. Once a female is nearby, some species switch to a softer courtship song that guides the final stages of mating. Cicadas can also produce disturbance sounds when handled or threatened, creating sudden bursts of noise that may startle predators. In addition, certain species use wing movements to create subtle clicks during close interactions. These variations give cicadas a flexible sound system that allows them to send different signals depending on the situation. What may seem like a simple insect noise is actually a structured set of acoustic behaviors shaped by evolution. One of the most striking features of cicada sound is how individual calls combine into massive choruses. Male cicadas often gather in large numbers in sunny trees and begin calling at the same time. As more individuals join, their overlapping signals blend into a powerful collective roar that can dominate the surrounding area. Scientists believe these choruses increase the chances of attracting females while also reducing the risk of predation. When thousands of insects call together, it becomes harder for predators to focus on a single individual. For human listeners, the effect can be dramatic, as entire landscapes seem filled with a steady wave of sound that rises and falls during the hottest hours of summer. The sound of cicadas is often treated as background noise, something that simply marks the height of summer. Yet behind that familiar buzzing is an intricate system of specialized anatomy, rapid muscle control, and natural acoustic amplification. What seems like a simple insect call is actually the result of tiny structures working with remarkable precision. In a way, cicadas turn their own bodies into living instruments, transforming mechanical pulses into signals that travel across forests and fields. The next time their chorus fills the air, it isn't just noise from the trees. It's the sound of thousands of insects creating one of nature's most powerful seasonal soundscapes. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.